Okay, so this is a little bit of an explanation of bubble sort. So I'm just gonna get right into it. Suppose we have some data, so bubble sort, and here's our data, 50, 30, 60, 40, 20. And a common theme that we sort of see in a lot of these quadratic sorts is you want to take part of this array and make it into a sorted array and keep the other part of the array unsorted. And slowly over time, we want to shrink the unsorted part and grow the sorted part. So the way that bubble sort does that is it compares every element to every other element to find sort of the greatest element at a time using swapping. So here's our array. Bubble sort starts at 50. And the first thing we do is we compare 50 to 30. 50 is greater than 30, so we can move it along. Or more properly, we can swap it. So 50 greater than 30, and so we will swap. And when we swap 50 and 30, we wind up with something like this. And so we'll continue where we are in the array. We were at the first position, and now we're at the second position. And now we're going to compare 50 to 60. 50 is less than 60, so we won't swap. And then now we sort of have a question. Are we going to stick with 50 or are we going to move on to the next index? And in bubble sort, it's the case that we're not going to touch 50 anymore. We're going to move on to the third index. So now we're looking at 60, 40, 20. So we're going through the whole array. We're not just sticking with one number. We go through the whole array. And 40 is less than 60, or I should say 60 is greater than 40, so we will swap. And if you notice the pattern, 60, once it's swapped with 40, will also be greater than 20, so we'll swap it as well. So what that's going to look like is 30, 50, 40, 60, because we swapped 20, and then once more, 30, 50, 40, 20, 60. And so 60 has actually been compared to every element in the array, because when we were looking at 50, we know that everything in front of this 50 has to be less than 50 because 50 swapped its way up here. Similarly, everything in front of 60 has to be less than 60 because 60 swapped its way up here. And so this part of the array is now sorted. We know 60 is the biggest element in the array. We know we won't need to touch it anymore. So now we only need to look at this part of the array. And bubble sort, it starts right at the beginning again. So, and I'm going to use this pipe to indicate the part of the array that is sorted. Ooh. So we start at 30, compare 30 to 50. 30 is less than 50, no swap. So 30, 50, 40, 20. Now we're at 50, compare 50 to 40. We will in fact swap because 50 is greater than 40. And we'll continue onwards, comparing 50 to 20. And likewise, 50 is greater than 20, so we'll swap it. And at this point, 50 has been compared to every element in the array. So we know that we can sort of move this line back here. Now this is sorted. We won't need to touch 50 anymore. And this is unsorted. So just to finish us off, 30 compare with 40, no change because 40 is greater than 30, so no swap. And then 40 compare to 20, 40 is greater than 20, so we'll swap it. So 30, 20, 40, and then Here's our sorted. And 40 is actually the end there, so there you go. 30, 20, swap. And we would move our pipe over here. And so 20 is just alone by itself. And so we know that's now in order. So that is the algorithm that makes bubble sort work as an example. Thanks for watching.